Okay, I thought I would go through this just because if it's 2018, you know this was an issue in class today. All right, so normally, if I'm going to take the limit, of all this, we talked in class about how this represents the height of the function and this represents the base. Well, normally when we would calculate that before, what we would do is we would have said that was 3 minus 0. And we're going to make n rectangles, so it would be 3 over n. That would describe the width of a rectangle. But then it was kind of like, okay, we're going to be going through this sum, and we're going to have to index it. So we might have put 3n out front, but I would have to put an I, or I actually had to put an I with it to show which rectangle I'm on, okay? Now, so normally we would have made this the width. The problem is here, they're telling us that that's not going to work out. They're going to tell us to use this. That was the hint they gave us. That's telling me there's something funky going on here. So now how could I describe this change in x? Well, the change in x would be the value minus the preceding value. So what they're saying is let our value, our x, be 3i squared over n squared. And what we're going to do is we're going to subtract the preceding value. Well, the preceding value, if I'm on I in the index, let's say I'm on 5. Well, I would say, well, the x at 5 minus the x at 4, or the fourth x, the fifth x minus the fourth x, would give me my change in x. I could take 1 and subtract the 1 in front of it, and I could get my my change in x there. Well, so what I'm going to have to do is say, this is 3i squared over n squared, and I'm going to have to subtract the preceding value from it. Now, one of the examples in the book, they did something like this, and again, this is funky because this is not our normal thing. This is a really abnormal problem compared to the other ones. All right, so, and I'm going to have to square this because, again, they told me this is what I was going to have to do. So to calculate my, since this is the c they want me to use, usually the c would have been, the x would have been 3 over n, but they're telling me use this instead. That looks a little weird, so I've got to make sure I'm actually getting a change in x here. So I have to take the value, subtract the preceding value. Well, just the algebra on this is fun. Again, we're going to do as much of this as we can on the video, and then I'll just, refer you to the worked out instructions that I've posted on course sites. Okay, so this would be 3i squared over n squared. Now, what I'm going to do, let's see, let me do this. Let me factor out the 3 and the n squared from both of those terms. What I'd have left would be I squared minus I minus 1 squared, okay? So all I'm going to do is try to simplify this expression the fastest way we can think to do it. All right, so this is 3 over n squared, and then if you think about it, this is going to be I squared minus, and in parentheses, if I multiply out I minus 1 times I minus 1, that would be I squared minus 1i minus another I would be minus 2i, and then negative 1 times negative 1 would be a positive 1. Okay, so let me try to squish this in here, then I'll go to a new page. This would be 3n squared times I squared minus I squared. Got to put the subtraction sign with that. Now, minus a minus 2i would give me a plus 2i, and minus a positive 1, negative times a positive 1 would be a negative 1. Now, if you look at that, your I squared minus I squared, those would add up to 0, and you'd end up with 2i minus 1. Okay, and so, okay, so that value we calculated, remember, that was our change in x. This is a weird problem because we're having to figure out how to think about our change in x, given that they told us we had to let the x value, the c of I, remember, that's going to be our x value, let it be 3i squared over n squared. Well, that's just an x value. That's not a change in x value. That's why we had to calculate this. So all this right here in red is actually just our change in x. So now I need to describe this part right here. Well, that's the function out value. And if you remember, the function was just the square root of x. But they also told us, remember, we're getting back to that hint again, that we were supposed to use 3i squared over n squared. They knew if we just used 3i over n, it would not work out right. So that's why we're having to go to a lot of extra work on this problem, and it doesn't really, it may be hard to understand, you know, why here. I think this is not going to be on a test, but I do, you know, we do want to go through it and try to learn something from it. All right, so what that would mean, how can I describe this function value here? Well, that would be the square root of 3i squared over n squared, which would be square root of 3, and then outside the radical we would have had an I over n. I'll just stick it out front. So now if I put these parts together, I'll write this in kind of a different color here. Let's do this. I need to do this. I've got the sum I equal 1 to n. Oops, sorry, there's a little extra dot there. And then I got to put in this I square root of 3, square root of 3i over n. I'll just put I over n square root of 3. Doesn't matter how I write it, I guess. And then I've got to put in that 3 over n squared times 2i minus 1. So I've got this sum now, and in a bit I'm going to take the limit as n approaches infinity. I need to use all my summation formulas for these i's here. So we'll go as far as we can. Won't finish it, I'm sure, because the algebra on this gets a little tricky. All right, so what I did for this is I went ahead, since all this is multiplied, let's pull out some stuff. Let's factor out an n cubed, because we got this n and this n squared here. So out in front of my sum, I'm going to kind of pull some stuff out for a minute just so I can get my i's isolated. So I'm going to have an n cubed on the bottom. And on the top, I'm going to factor out that 3 and that square root of 3. There we go. Can't get this stylus to write. Okay. So that's out front. And then now what I've got left, if you look, I've got an I left and I got a 2i minus 1. Let me go ahead and multiply that out. I'm just going to do it above it to save some space. If I multiply this out, this is going to be 2i squared minus I. Okay. So now what I'm going to do, remember that's kind of replacing all this mess here. I'll just go ahead and write that down. All right, so the next step, I'm going to keep my 3 square root of 3 n cubed out front. So let me write that down. I can't even read it. The stylus is so hard to write on with this app. Okay, so what I'm going to do is I'm going to go ahead and I'm going to split this up. So I'm going to give each one of these terms in here its own sum. And so for the 2i squared part up there, I'll just kind of color code for this 2i squared part. I'm going to pull the 2 out front, and I'm going to say that's the sum of I equal 1 to n of I squared. And so in a minute I'll be substituting that formula. And then here I've got a minus I. So that's the minus the sum I equal 1 to n of just I. And again, that 3 square root of 3 is going to get multiplied by all of it. So I'm going to go to a new page. Okay, you might have seen another slide flash up. I forgot to turn it back on and talk, so I just rewrote it instead of trying to backtrack. All right, so if you look, what I've done is I put the 3 square root of 3 and the n cubed out front, and then for that sum, that was 2 times the sum of I equal 1 to n of I squared. So my 2 is right here. And then this n times n plus 1 times 2n plus 1 over 6. That's the formula for I squared. And then we were supposed to subtract, and then I had a sum with an I on it. And the formula for I was n times n plus 1 over 2. So what I decided to do for my algebra here, and again, you can do, there's different variations of this. I went ahead and distributed that 3 square root of 3 n cubed at this point. So for my first term, 3 times 2 was 6. And then there's a square root of 3, and then I have n cubed on the bottom, and then I have n times n plus 1 times 2n plus 1. And I'll come back and distribute that in a minute. I'll simplify that. Now on the second term, I would have 3 square root of 3 on top, and then I would have the n times the n plus 1. And then on the bottom, I would have 2n cubed. Hopefully I'm not making too many mistakes here. This is hard. I'm going to, each line I'll kind of put in a different color so you can kind of keep it straight. Now, n goes into n once, and n goes into n cubed, n squared times, so I could reduce that part. Oh, I forgot to put my 6 down. See, there's a 6 here, and let me copy it down, because that's going to cancel out with that. And so what I'm going to have left on this first term here would be a square root of 3. And then I've got this n plus 1. Let me see, I'm going to keep up with my n squared on the bottom so I don't forget it. And then if you kind of FOIL this out or distribute this out, that would be 2n squared. And you'd have plus n plus 2 more n would be plus 3n. And then 1 times 1 is 1. So that's the whole first term now. And now if I go over here to this other one and look, I could cancel out 1n, and that would cancel out, make this an n squared on the bottom. So I'd have minus 3 square root of 3 times n plus 1 over 2n. Let me go ahead and even distribute that. Negative 3 square root of 3 times n is a minus 3 square root of 3n. And negative 3 square root of 3 times 1 would be negative 3 square roots of 3. So now my next step is going to be, if you remember, let's see, I actually probably should have gone ahead and distributed that square root of 3 on this first term here. For instance, right here, I need to distribute that. So let me go ahead and do that. That's going to be 2 square roots of 3 n squared plus 3 square root of 3n plus square root of 3. And now let me just go ahead. I distributed it, but remember what I end up doing is I split these up into individual fractions. You only have one term on the denominator, so I can put an n squared under each one of those and split it up, because I'm almost ready to take the limit here. Alright, so I'm going to do the same thing over here. I actually already multiplied it out, so I'm just going to put minus 3 square root of 3n over 2n, and then, oops, that's 2n squared. I didn't copy that here, so catching those things as I go. And then minus 3 square root of 3 over 2n squared. Okay, is that right? Hopefully. Okay. So now I'm ready to take my limit. Now, let me go ahead and reduce these a little bit further. This is going to be 2 square root of 3. 1n on top will cancel out with 1 on the bottom, so this is plus 3 square root of 3 over n. And then I got plus square root of 3 over n squared. Now, over on the second term, 1n here will cancel out with 1 on the bottom, so that's minus 3 square root of 3 over 2n. And then nothing's going to cancel out over here. So I'm ready to take my limit. Now, as I take my limit, if you remember, anything that had this 2 square root of 3 is going to stay. If I plug in, now I'm just going to go ahead and put my limit out front here just to show that I'm taking my limit. If I put in infinity for n, that number over infinity is going to go to 0. Got a variable on the bottom, that one's also going to go to 0. Got a variable on the bottom, that's also going to go to 0. Got variables on the bottom, that's also going to go to 0. And my answer is just 2 square roots of 3. So that's actually number 1. And hopefully that helps you be able to go through it more step by step. You know, one of the things about it is, notice that all these terms down here all have these zeros. If I made a little algebra mistake and forgot to do something with some of the numbers, it almost like it accidentally works out just because you've got more n's on the bottom. So, you know, I'm not sure if you see that I should have canceled out a 2 and I didn't. I think this is right. But if there's anything you kind of notice, a lot of times what's going to happen is, as long as you've got a variable on the bottom, the whole term's going to go to 0 anyway. So sometimes when you make small algebra mistakes, or you forget to write something down, it actually works out, because a lot of the times the terms are going to go to 0. I hope this is right. Anyway, the end result is 2 square roots of 3, and I know that's correct. So.